So your name is Hobbie Willis, and you work for the Utah Geological Survey, and your field of science is, I'm a geophysicist, but I study gravity and how it changes in different parts of Utah. Geophysics is a field that covers a lot of different studies. Alright then, question 1. What courses can you take through high school to help you prepare for being a geophysicist? It honestly depends on the high school you go to. Some high schools will have you take an earth science class in 9th grade that lasts a semester or longer, and some high schools don't, depending on their available staff and other course restrictions. Regardless, geophysics requires a college education, so it's important to take math classes like geometry, algebra, and trigonometry. Science classes like chemistry and physics, and English classes, because all science involves lots and lots of writing. Doing well in these classes will help you get ready for college-level classes, but it's important to be a well-rounded student, too. Don't slack on history, take a fun class or two if you can. Interesting to know. Question 2. What are the steps you can take through your first degree in college for a Bachelor's of Science? For a Bachelor's of Science, there are a couple of routes you can take. Almost any college will require you to take a lot of the same classes as everybody else the first 2 years, no matter what you were studying. So sometimes you can go to a smaller college and won't have as many students taking these beginning classes. The majority of all geophysicists that I know all started by taking the same geology classes as regular geology students. If you're a really hard-working student, you can start on the geophysics path from the very beginning by taking different physics and math courses. However, all good colleges will have academic advisors who will sit down with you as you begin with your college education to plan out what classes you will need to fulfill the school's requirements. Once again, geophysics will require many high-level math classes in addition to your geology and geophysics classes. The next question is related to the last one. Are there any steps you must take beyond a Bachelor's of Science to become a geophysicist? Yes, many careers in geophysics require a master's degree or PhD in order to qualify for the position. This adds more classes and more years onto your education, though it can be well worth the effort if you want to study something like the waves of energy on the sun, or if you want to be a professor at a college. Pursuing a master's or PhD is a lot of work, but it means you'll be one of the top minds in geophysics. It's a decision everyone has to make on their own when they are in college. Getting into a college for graduate work after a bachelor's is very competitive and can sometimes take a couple of years of applying just to get in. Sounds like you have to be pretty dedicated to your studies if you ever want to become a geophysicist. Yes, you definitely have to love what you do if you pursue this career. How popular is geophysics? How many people are involved locally, statewide, and nationwide? Does this indicate that there's a high demand and opportunity for people going into geophysics or not? I don't know that popular is a word I would use to describe geophysics. There are certainly lots of us in the world, but it's not a career you hear about very often. However, depending on the organization, there can be several geophysicists working in one place. Oil companies, mining companies, engineering companies, and other similar agencies can often employ dozens of geophysicists for just one job. On the other hand, here at the Utah Geological Survey, there are just 2 geophysicists. There are a handful of seismologists who work at the University of Utah's seismograph station who keep an eye on the earthquakes in Utah and in Yellowstone. Then there are more geophysicists who work for places like Rio Tinto, Kennecott, Utah Copper, other Utah coal mining companies, and various other groups. So I'd say there are maybe a few dozen of us in all of Utah. There's never very high demand for geophysicists in the world, and the positions that do open up are filled very quickly because there are plenty of available geophysicists. Good advice to hear if you're thinking of going into the field. Next question. What is the schedule that you normally work? Do you work indoors in the office or outdoors in the field? Are there any instances where this changes? I am very lucky because working in geophysics does provide me with a different work schedule than most people. April to September is what I call my field season. It's the time of the year when the weather is usually pretty nice and when I get the majority of my field work done outside around the state. I travel out of Salt Lake to places all over the state. When I have a field work that needs to be done, I get to work outside every single day. Unless it's very windy, rainy, or snowy, I can sometimes work 10 to 14 hours a day depending on how big a project is or how quickly I need to complete it. For the majority, I work 10 hours a day, 4 to 5 days a week when I have regular field work to complete. Then when the weather starts to get bad in October, I work in our Salt Lake's office every day. The data I work with requires a lot of attention and it's been collected so I spend the winter months working a pretty regular 9 to 5 in the office processing data, or working on projects with other geologists here at the UGS. So you're not always stuck inside with your job. No, I do get out, and I do get to go out and see the state with my job, which is awesome. Alright, next question. What are the conditions of your career? When I'm working in the field, I'm almost always alone, which can be a little dangerous if I'm not very careful. When I work in the more remote places of the state, like the West Desert, I sometimes won't see another person all day. On top of that, I will frequently go without self-service all day, and so I take a special satellite phone in case of emergencies. Since I am alone and can't easily call for help, I have to be very careful when I'm driving or riding my ATV. However, my job utilizes special instruments that need to be charged every night, and so I usually stay in a town not too far from where I'm working. Question 7. What is the annual salary of a geophysicist? This is a very difficult question to answer, as it changes so much with where you work and the level of education and experience you have. I know some geophysicists who work for oil companies can be paid in the range of $75,000 to $90,000 per year. If you have been trained by a company to do a very specific, very specialized job, your salary can be even higher. But the average salary of geophysicists can range from $55,000 to $75,000 per year with a master's degree or higher. Question 8. What opportunities are there to advance as a geophysicist? Like many other jobs, there's a lot of room for advancement in geophysics. Again, depending on who you work for, most geophysicists have to start in an entry-level position with other scientists and work for a few years before they can move on to managing projects, developing new ones, and supervising other geophysicists. As you continue to work with a company, you can earn more money as you become responsible for bigger and bigger projects. If you work hard and you do a good job, then you'll most likely move up. There's a good chance, yes. Question 9. What are typical problems that occur in your job? Are there any downsides? Geophysicists are scientists, and so we run into a lot of problems. The two most common problems in my job are bad weather and funding. The instruments I use are a little delicate, and working in bad weather can damage them or reduce the quality of data I collect. Sometimes I won't have enough money in my budget to do as many measurements in a project area as I would like, which means the overall usefulness of the maps and data I produce is reduced. I can run into other problems like flat tires, dead batteries, land that I can't access, getting stuck in the mud or snow, or incorrectly collecting data. Fortunately, if I'm careful and plan ahead, I can avoid most of these problems. Sounds like it can be frustrating sometimes. Yes, but all scientists have to deal with things like this. Question 10. What are the positive things about being a geophysicist? There are a lot of really amazing things that geophysicists get to do. And as a result, we have a lot of really cool information that we can tell people. My job isn't quite as high profile as other geophysicists, but I do help produce some useful information. The data I collect is used to make maps that show how gravity changes across different sections of the state. Other scientists and engineers use this information to figure out the geologic structure of an area, look for geothermal potential, or help identify buried faults. That last one is pretty important for certain areas of our state. Other geophysicists work on finding new sources of oil or ore, help engineers build safe, stable buildings, or monitor earthquakes. Question 11. What professional associations are available to join? There are dozens of organizations that geophysicists can join, ranging from state to international groups. There's the Utah Geological Association, which all Utah geologists and geophysicists can join. Then on the national level, there's the American Geophysical Union. It all depends on the specific type of geophysics you study. Question 12. Are there any possibilities of being an educator in this career? Once again, since geophysics is a fairly broad study, there are lots of opportunities to become an educator. The UGS loves to teach students in Utah about what geologists and geophysicists do, but you can pursue any number of educational opportunities. You can become a college professor or lead specialized work groups that travel and work all over the world.